In this video, we'll be seeing about root formation. So root formation is something which will be beginning towards the end of advanced bell stage. And when it will begin is once the enamel and dentin formation in the crown region has reached cervically to the future cementoenamel junction. That is a point where cementum and enamel meets. Once the enamel and dentin formation reaches this point, there will be beginning of root formation with formation of Herwig's epithelial root sheath. So what is Herwig's epithelial root sheath? Herwig's epithelial root sheath was something which was discovered by Oscar Herwig and hence named after him in the year 1874. He discovered it in amphibian species and not in mammalian species. It was discovered in amphibian species. And this is thought to originate from cervical loop. So cervical loop we saw in the previous videos of bell stage, that is when enamel organ bends inward, that point is called as cervical loop and it has only two cells. It has only inner enamel epithelial cells and outer enamel epithelial cells. Now we will come and see what is Herwig's epithelial root sheath structure. So Herwig's epithelial root sheath, this diagram is a magnified view of this portion. So they also contain two layers of cells, that is same cells, that is inner enamel epithelial cells and outer enamel epithelial cells. And they also have two basement membrane. One basement membrane which will be separating the hairs from dental papilla, and in the other side the other basement membrane which will be separating it from dental follicle or dental sac. So it has two layers of cells and two basement membrane. So it does not have the stellate reticulum and stratum intermedium layers of cells. Okay. Now here outer enamel epithelial cells are the same cuboidal cells and inner enamel epithelial cells will be remaining undifferentiated because if they undergo differentiation, there will be formation of ameloblast and we will have enamel formation. In root, we do not have enamel. We have pulp, dentin and cementum. So here, these cells remain undifferentiated. Now, we have to know what is epithelial diaphragm. So, as the Herwig's epithelial root sheath forms from this portion, they will bend in an horizontal way, in an actual 90 degree they will bend. And this is called as epithelial diaphragm. The bending of Herwig's epithelial root sheath in a right angle, in a horizontal manner, we call it as epithelial diaphragm. And they will not meet in the central portion. They will not meet in the middle portion. And this bending of epithelial diaphragm, this epithelial diaphragm will be moving in an apical manner, and as it moves apically, this opening in the middle will be getting narrowed. This will be getting narrowed, and thus the root formation will be completed. So as it moves apically, there will be narrowing of the opening, that is called the cervical opening, or that is a future apical opening of the tooth, and the root formation will be completed. Now we have to see how dentin and cementum is formed in the root portion. So for all these to happen, Herwig's epithelial root sheath is important. So first, Herwig's epithelial root sheath will be signaling the dental papilla. They will be signaling the dental papilla, and there will be formation of odontoblasts. Odontoblasts are the cells that form dentin, and dentin formation will be beginning. So once Herwig's epithelial root sheath has signaled the dental papilla, the dentin formation will be beginning, and once dentin formation has reached completely apically, once it has reached completely apically after the formation of odontoblast, the Herwig's epithelial root sheath will be undergoing degeneration. They will undergo degeneration, or they will be break in the continuity of the cells. So in some portions they will undergo degeneration, and in some portions the Hervix epithelial root sheath will be remaining. So in this side we know we have dental follicle. So these dental follicle cells will come in contact with dentin in the portions where there is no Hervix epithelial root sheath, or in the portion where Hervix epithelial root sheath has undergone degeneration. The dental follicle will come in contact with dentin. When dental follicle comes in contact with dentin, there will be formation of a new cell, that is cementoblast. So here there will formation of new cells, that is cementoblast. So what are cementoblast cells which form cementum? And thus cementum formation will be occurring in this region. So that is how dentin and cementum is formed. So first, Hervix epithelial root sheath will be signaling dental papilla and dentin formation will occur. And once the main function of dentin formation is over, the Hervix epithelial root sheath will have a breakdown. There will be loss in the structural continuity, and where there is loss of Hervix epithelial root sheath, dental follicle or dental sac cells will come in contact with the dentin through these openings, and there will be formation of cementoblast, and then cementum formation it will be helping. So now I will show this in a separate flow chart so that you can understand it more better. Now as a flow chart I have shown how dentin and cementum formation is taking place. So saying it again, as Hervix epithelial root sheath is formed, it will signal the dental papilla on this side, and the dental papilla cells will be differentiating to form odontoblast cells, and the odontoblast cells will be depositing dentin. And once dentin formation has occurred, that is the main function of Hervix epithelial root sheath is over, these cells, Hervix epithelial root sheath cells, will undergo degeneration. There will be loss in the continuity of the cells, and in some places there will be no Hervix epithelial root sheath, in some places there will be Hervix epithelial root sheath. So in places where there is loss of Hervix epithelial root sheath, the dental follicle cells will come in contact with the dentin in this side, and there will be differentiation of cells of dental follicle to cementoblast. In this side, cells of dental follicle will differentiate to cementoblast, and there will be formation of cementum. So that's all about dentin and cementum formation taking place in root formation. Now we have to know what are the functions of Hervix epithelial root sheath. So we mainly have three functions. First one is Hervix epithelial root sheath will determine the number, size, shape and length of root. It will determine the number of root, size of root, shape of root and length of root. Second function is it will determine the dentino-cemental junction. So we saw in this place there will be Hervix epithelial root sheath, and they will lose, and once it loses continuity, in this side there will be formation of cementoblast. So this side there will be formation of cementum, and this side there will be formation of dentin. So this is the one which will be marking the, or which will be establishing the dentino-cemental junction. And third function is, this is one which is helping in the formation of dentin and cementum. So these are the three main functions of Hervix epithelial root sheath. Now we have to know how multi-rooted tooths are being formed. So I said there is formation of epithelial diaphragm, and this epithelial diaphragm will come and not meet in the middle, and they will move apically, and there will be narrowing of this cervical opening and a root will be formed. But in two roots we should not have one opening, right? There will be 2 or 3 cervical openings and separate 2 or 3 root. So in multi-rooted tooth, how this happens is there will be formation of 2 or 3 epithelial diaphragms, and there will be separate cervical openings. So now when you see, lower molars will have 2 roots. That is, in cross section we will have 2 separate epithelial diaphragms. There will be 2 separate epithelial diaphragms, and they will form 2 separate roots. In upper molars we can see there will be 3 roots. There will be 3 roots, and there will be formation of 3 epithelial diaphragms which will go to each other and they merge together and form. There will be 3 epithelial diaphragms which will go towards each other and they merge and form 3 roots. Now we have to see what are the fate of this cervix epithelial root sheath. So first fate is, these cells, as they undergo degeneration, there will be some remnants of cells remaining. There will be some remnants remaining, and they will be entrapped in the periodontal ligament, and they are called as cell rest of molasses. They are dormant cells, and they may give rise to pathogenesis like cyst or tumor in future. The second fate is, if the cervix epithelial root sheath does not undergo degeneration and they remain in the same place, then what happens is they become adherent to the dentin. If one place, if the cervix epithelial root sheath is not undergoing degeneration, they will become adherent to the dentin and they will undergo differentiation and they form amyloblasts. So as they remain for a long time, they will undergo differentiation and they will form amyloblasts, and there will be formation of enamel at this portion that will remain adherent to the root. That is called as enamel pearl or enamel droplets. Now we also know we have many accessory canals found in root. So we will see how the accessory canals are formed. If the cervix epithelial root sheath undergoes degeneration before dentin formation, then there will be formation of accessory root canals. So these are the fate of cervix epithelial root sheath. So in this video of root formation, we have seen what is cervix epithelial root sheath and how it is forming. It consists of 2 layers of cells. It consists of 2 basement membranes, and how cervix epithelial root sheath is helping in formation of dentin and cementum. Then we saw the functions. Then we saw what is epithelial diaphragm and how a single root and how a multi-rooted tooth is forming. Then finally the fate of cervix epithelial root sheaths. So that's all about root formation. Thank you. See you again in another video.